So the next topic is Ohm's law. We are going to learn one important law, Ohm's law. What do you mean by Ohm's law? The first time you are hearing Ohm's law, let me explain the definition. The definition is very, very important. If the definition is asked, you have to write it in words. You have to write the definition in words. The potential difference or voltage, okay? The potential difference or voltage across the ends of the given metallic wire. Here we have a metallic wire, okay? Some wire. The voltage across between the end points. The voltage or potential difference between the end points, that is V, is directly proportional to the current flowing through it. The current flowing through it, provided the temperature remains same. The temperature should be same. So the Ohm's law says that, you see that there is a voltage, understood? There is a voltage across this metallic wire. There is a resistive wire. Resistive means the current find it very difficult to flow through that. Current is very similar to the flow of the water, understood? Voltage is very similar to the motor, okay? The energy of the motor. Just like a water pump. This as a water pump. The current means the flow of the water in 1 second. So the more energy of the pump means more flow of the water. That is the logic. The more energy, you have seen the pump, like understood, 1 unit, 2 unit power, understood. So the more power of the water pump, more energy of the water pump results in more flow of the water. That is Ohm's law. Okay, similar to Ohm. Okay, so the Ohm's law says that the voltage is proportional to current. Understood? The voltage is directly proportional to the current. The more voltage results in more current. That is Ohm's law. In using symbol, what we can write? Voltage is directly proportional. There is a symbol representing directly proportional. Voltage is directly proportional to current. In symbol, using symbol, we can write like this. Voltage is directly proportional to current means if the voltage is doubled, the current will be doubled. That is the meaning of directly proportional. If voltage is increased by 10 times, the current will be increased by 10 times. So the directly proportional means that if the left side quantity is increased by 10 times or 5 times like that, in the same ratio the right side quantity will be increased. That is the meaning of directly proportional. If two quantities are directly proportional, what we can write? We can write that V equal to I into some constant. A constant means a fixed number. It is actually a mathematics, okay? If two quantities are directly proportional, what we can say? The left side quantity will be equal to I into some fixed number. A fixed number. That fixed number depends on the property of the metallic wire used. That fixed number depends on the nature of the metallic wire used. This fixed number is said to be. So V equal to I into a fixed number. That fixed number is a quantity, depends on the wire we have used across the battery. A fixed number which is called resistance of the wire. Resistance. The name is resistance, denoted by the letter R. It is the property of the wire connected across the battery. So V equal to I into a fixed number. That fixed number is said to be resistance of the wire. Resistance of the wire connected. So in short form, V equal to I into that fixed number is denoted by the letter R. That fixed number is denoted by the letter R. R is a number, fixed number representing this wire. Okay, so let me explain once again. So I am going to explain Ohm's law. Ohm's law means it is the relation between voltage and current. Voltage means every battery will have certain voltage, you know that. And current, you know that the charge flow. In 1 second how much charge is flowing, that is current. This voltage and current are directly proportional, that is Ohm's law. This voltage and current are directly proportional to each other, provided there is no rise in the temperature. The temperature must be fixed. Then voltage is directly proportional to current. That is said to be Ohm's law. So that is in symbolic form we can write like this: voltage directly proportional to current, meaning that if one quantity becomes 10 times, example, if one quantity becomes 10 times, automatically other quantity will also becomes 10 times. So if two, then we say that the two quantities are proportional. If two quantities are proportional, what we can say? The left side is equal to right side into a fixed number. A fixed number. That fixed number is a number representing the wire, representing this wire connected across the battery. A fixed number is said to be resistance. Its name is like that. Resistance denoted by R of the wire connected across the battery. So V equal to IR. This formula you have to understand. The V has the unit I explained in the previous class. Let me write like this, you can understand. V has the unit I explained in the previous class. Unit volt. 20 volt, 30 volt, like that. The current has the unit. The current has the unit ampere. 1 ampere, 2 ampere, like that. I explained in the previous class. And R is said to be what? Resistance. Its unit is a different unit. Maybe first time you are hearing about the unit of R. R is a fixed number representing this wire. So that fixed number has the unit ohm. 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 O. Its symbol is like this. It is a Greek symbol. The unit of resistance is ohm, denoted by the symbol like this. This symbol we are using. This is actually a Greek symbol. Okay. I will discuss problems. When I discuss problem, you can understand Ohm's law. So the next is activity which shows Ohm's law. Okay. How can we prove Ohm's law? We studied that Ohm's law says that voltage is directly proportional to current. If current voltage is doubled, current becomes doubled. How can we prove it in lab? In lab, can we prove it? Definitely we can prove it. Look at this diagram. You have to draw the diagram. You have to learn it. Okay, you have to practice it because it will be asked in exam. This will be asked in exam. Explain the activity proving Ohm's law. Okay. So this diagram you have to understand. I will explain this. You have already studied diagram, circuit diagram. Here we have 4 volt batteries. Understood? You can see 4 batteries. Say something like 1.5 volt battery. Understood? In clock and remote, have you seen a small battery like this, a cylindrical in shape? 1.5 volt battery. We need 4 such batteries. Okay. We need not only one battery, we need 4 such batteries that should be connected like this. This left end meaning that positive terminal of the battery. Clear? Like understood? This is the symbol of the battery. You studied in the lower classes. This long line represents actually positive terminal. The short line actually represents the negative terminal. Positive terminal and negative terminal. So plus minus, plus minus, plus minus, plus minus. Series connection. The battery is connected like this. So 4 such batteries are required. because in order to for more current, more voltage is needed. That is the reason. So okay, then a connecting wire is there. Then the entire text I will show you. I will read it. You have to listen carefully. Set up the circuit shown in the figure. Yes, you have to draw this. I will explain each part. Don't worry, I will explain each components. Set up a circuit shown in the figure consisting of nichrome wire XY of length 0.5 meter. Nichrome wire, it's a special type of wire. Nichrome wire is a special type of wire. It will not becomes hot. Clear? If the current passing through the nichrome wire, it never becomes hot. The temperature should be fixed, then only Ohm's law satisfy. The temperature should be fixed. So the nichrome wire is a special type of wire which will not be hot when the current passing through that. So consisting of a nichrome wire XY. XY is a special type of wire having length 0.5 meter. If you don't include this 0.5 meter, you will get marked, don't worry. The nichrome wire should be specified, okay? Length whatever it may be, no problem. Say 0.5 meter. An ammeter. Ammeter means it is the device which measure the current. Ammeter means it is a device which measure the current. Ammeter, you might have seen that there is a reading, okay, it's for purpose of taking reading. There is a needle here on that device. 0, 1, 2, 3, 4, 5 will be written on that device. If there is current, this needle will show the value. If 1 ampere is current, 1 ampere current is flowing through this wire, this needle will be pointing towards 1. If 10 ampere is flowing through this wire, this needle will be pointing towards 10. Ammeter, A is ammeter which measure the current. A is the ammeter which measure the current. I want how much current is passing through this wire. I need it. So nichrome wire is there. The ammeter which measure the current. Everything is written. Ammeter, voltmeter. Voltmeter means it measure the potential difference. Potential difference across nichrome wire, not the battery, not battery potential difference. From this point to this point, what is the potential difference or voltage? How much voltage between these 2 points? Clear? Voltage I explained. How much energy is required to transfer 1 coulomb charge from this point to this point? That is voltage. I will repeat. I will interact with you. Please listen. The voltage across the 2 points means what? How much energy is done? How much work is done? How much work is done for transferring 1 coulomb charge from this point to that point? Understood? A charge is flowing like this. How much work is done? So the potential difference or voltage across the nichrome wire, we have to measure it. So we will connect a voltmeter. Voltmeter is a special device. Voltmeter is a device which measure the potential difference or voltage across the nichrome wire. So voltmeter is V, denoted by V, and 4 cells are there. Yes, I told you, having 1.5 volt. Smaller batteries, 1.5 volt each of them. Nichrome wire is a special type of alloy. Consists of nickel, chromium, manganese, iron, metals. This may be asked as a multiple choice question. Nichrome is a alloy. Alloy means it's a mixture of certain metals. Alloy means mixture of metals. Nickel, chromium, manganese, iron. First use only one cell. First we use only one cell. Only this one is used. Other one is not connected initially. Initially we are not connecting other 3. Only 1 volt battery is connected. First use only one cell of the source. Not the reading of the current and voltmeter reading. Okay, so when one single cell is used, we have to measure what? We have to measure the voltage across the nichrome wire and the current through the nichrome wire. Only one cell is connected, then we will measure how much voltage across these 2 points and how much current is passing through this wire. We have to prove that voltage is directly proportional to current. So the reading of this voltage and current to be measured. Understood? The reading of this voltmeter and current to be measured. Okay. Now, so initially only one cell is connected. Only one battery is used. Other battery is not used initially. We will measure the voltage across the nichrome wire and the current through the nichrome wire. Voltage across the nichrome wire and current through the nichrome wire. Measure. Next, we will note it. Okay, we will note it. How much voltage and how much current. We will note it somewhere. We will note it somewhere. The next, connect 2 cells. Initially only single cell is used. Now I am going to use 2 cells. These 2 cells are used, other 2 not considered. Okay, now in the next step what we are doing, 2 cells are connected. As a result, the more flow of the current will be there. If you use 2 batteries at a time, the more current will flow. If you use 3 batteries, then again the current will be increased. So now in the next step we are using 2 batteries together. As a result, definitely the current will be increased. So we repeat the experiment. I mean, we will measure the voltage. When 2 batteries are used, we will note the voltage and we will note the current. And we repeat this process. We repeat it. In the next time, what we will do? We will use 3 batteries. We will use 3 batteries. Other one is not considered. And then we will note how much voltage across the nichrome wire. There is a device. Just looking at the device, we can measure that. The voltage, how much voltage across the nichrome wire, how much current is passing through the nichrome wire, that also we can measure. And finally, all the 3 cells, all the 4 cells are used. As a result, everything will be increased. We will note the voltage and the current. We have to prove that V equal to IR. This is actually Ohm's law, right? R is a fixed number, does not vary. R is a fixed number, does not change. So each time you have to find out V by I. I will show the table, don't worry. Each time you have to find out what? Each time we have to find out V by I. Each time. Because V by I is R actually. Ohm's law is V equal to IR, or V by I is equal to resistance. V by I is equal to resistance of the nichrome wire, which does not change. So V by I, we are checking whether V by I fixed or not. First we have a voltage and current, we will find out V by I. In the next time also we will find V by I. So every time we will find out V by I. Every time we get V by I a fixed number. We get V by I as a fixed number every time. Meaning that V by I is a constant. V by I is a constant. So V equal to I into a constant. V by I is constant means V equal to I into constant. So that is the Ohm's law activity. Proving the Ohm's law is this. So we will find out V by I. The ratio will be fixed. Ohm's law says that V is proportional to I, or in simple language, V by I will be a fixed number. Okay. Okay, clear. So here is the circuit. So what I am saying is, so we are doing an experiment. The 4 stages is required. 4 steps are required. Initially, number of cells used in the circuit. Initially we use only single cell, that is 1. In the next stage, we will use 2 cells. In the third stage, we will use 3 cells, and finally we will use 4 cells. Every time we will measure the current and potential difference. There is a device for that. The current through the nichrome wire. A table to be drawn. In exam, if they ask for the activity, you have to draw this table also. The current through the nichrome wire. There is a table here. The current through the nichrome wire. This is the current is measured by the ammeter. Ammeter is a device which measures current. How much current is flowing through this nichrome wire? Just look at the device, you will get it. So every time you have to note the current as well as the potential difference across the nichrome wire. I mean voltage across the nichrome wire. You have to note it. And each time you have to find out V by I. V by I, you will get a fixed number. You will get a fixed number. That fixed number is said to be resistance, because V equal to IR. Understood? V equal to IR. So naturally V by I will be R, where R is resistance. A fixed number does not change. So you can prove that every time we are getting a fixed number. V by I is a fixed number. Okay. In this diagram, the K is a switch. K is switch or key. Another name of the switch is key. Key is the switch. When the switch is on, we can measure the voltage and current. If the switch is off, we cannot measure it. Okay. Look at this question. How much current will an electric bulb draw from a 220 volt source? How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohm? The second part I will discuss later. Let me discuss A part. How much current? Actually, the diagram is not required. But if you don't understand the question, I will show the diagram. Okay. Bulb is denoted by this symbol. Resistance, actually the resistance meaning that to what extent it prevents the current from flowing. The more resistance means what? The more resistance means it offer high resistance against the current. High resistance against the current. Okay. Less resistance means the current can easily flow through the conductor. The current can easily flow. So more resistance means more difficult for the current to flow. So the current will be smaller. More resistance means that the current will be smaller. So the entire resistance is here. Bulb filament. Okay. The other portion does not carry any resistance. Clear? It's a aluminum wire. Aluminum wire does not prevent the current from flowing. So this portion does not have any resistance. All the resistance are there here. This thing prevent the current from flowing forward. Actually, this diagram is not required, just to understand. I am explaining this. Okay. So here the voltage is given as 220 volt. Given in the question, you please read it. The resistance R is given as 1200 ohm. Current is actually the flow of current. Normally we show the current starting from positive terminal. Actually the electrons are moving from negative terminal. By convention we show this arrow. Okay, you need not worry about that. Some current is flowing through the bulb. So I is our question. So we have a formula. Ohm's law says that V equal to IR. Ohm's law says that V equal to IR. Ohm's law. I want current, right? Okay, no problem. R can be taken to the left side. This formula you have to memorize. If I want I, okay, R can be taken to the left side. The current through the bulb equal to V by R. R is taken to left. V is the voltage, it is 220. Voltage across the bulb is 220. R is the resistance, it is given 1200. Simplify this. 10 cancels. 22 by 120, you just do the division. Okay, you just do the division. I don't want to explain the division part. If you don't understand the division, you please tell me, I will clarify. Okay, 22 divided by 120, you can do the division. You will get approximate value 0.18. You know how to divide, right? It's very simple. Point is to be written, 1 to be written like this. In this way you can proceed like this. Very simple. After point, only 2 digits to be written. No more further simplification. I is having unit ampere. So the current through the bulb will be 0.18 ampere. Okay. Do one thing. Please answer the second question right now. It's very similar to the A part. Only the number is changed. You have to answer. Send me the answer right now. The only thing is the value is changed. The same technique, okay, the same technique we can use. The figure is not required. V equal to IR and solve it. Look at this question. Look at this question. The potential difference between the terminals of a electric heater is 60 volt. I don't want to draw the diagram. No need. Okay. The potential difference between the potential difference or voltage between terminals of the electric heater is 60 volt. Voltage is given as 60 volt. It draws a current I is equal to 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt? It's a very good question. It's a very good question. So what we can do? What we can do? Anyway, since V and I are given, let me find out resistance. Actually, the resistance is not asked in the problem, but since V and I, both V and I are available, let me find out that fixed number representing what? Heater. Every component, I mean bulb, heater, fan, fridge, AC, everything having certain resistance. It offers some resistance against the flow of the current. It is a fixed number. The resistance of the electric heater will be a fixed number. Since V and I are available, let me find out R. It may be useful. We know that the Ohm's law says that. Ohm's law says that V equal to IR. Never forget it. Ohm's law says that V equal to IR. V and I are available. Okay, we can find out that fixed number R. I can be taken to the left side. R equal to V by I. Understood? I can write R equal to V by I. V is 60. V is 60 and I is what? I is 4 ampere. 60 by 4, you know that. I don't want to explain that part. R equal to 60 by 4 will be 15 O. Remember, it never changes. It is a fixed number for a given heater. For a given electric heater, this R never changes. Whatever may be the voltage and current, the R value never changes. Now we are going to change the voltage. We have freedom in changing voltage, right? Initially the voltage was 60. Later I changed the voltage. Initially it was 60, but we have freedom in changing voltage and current. If we change, we are going to change the voltage to 120. but still the resistance of the electric heater remains the same. I got 15 ohm. The resistance will never change. Even if you change the voltage and current, the resistance, it will be a fixed number. So V is given, R is 15 ohm. We have to find the current in this situation. In this situation, how much current will be passing through the heater? Understood? So again use Ohm's law. Ohm's law is, every time Ohm's law is applicable, V equal to IR. But in this case, I want the current through the heater. R can be taken to the left hand side. We get I equal to V by R. We get I equal to V by R, isn't it? R go to the left side. I equal to V by R. I equal to V by R. V is 120 and R is 15. 120 by 15, what is the value? 120 by 15. Shall I discuss that division? You can do the rough work. You can do the rough work. Let me do the division. You will get 8. So the final answer is 8 ampere. So if we change the voltage to 120 volt, the current will be 8 ampere. Okay.